Hi everyone. Today we're going to learn how to graph inequalities on a coordinate plane, but before we do that, I just want to review going over graphing an equation. So just a simple equation, y equals x. If we look here, it would start at 0, 0, go up 1 over 1, up 1 over 1, or down 1 over 1 to the left, and it would create this line right here. Everywhere on that line, the y value is equal to the x value. So for instance, like if we were to just make a table of, if we were to make a table of values, when x is -3, y is -3. And when x is 0, y is 0. And when x is 4, y is 4, because the y value is always equal to the x value. For an inequality, for instance, so let's just use another simple example. Y is greater than x. If we were to like come up with a table of values there, I mean, you could come up with like an infinite amount of points here, but for let's just say the x value was -3, just anything larger than -3 would work because this is why it has to be greater than the x value. So -3, -2 would be a good point to use. Another point that would be good to use would be like -3, 5, right? Literally anything where the y value is greater than the x value. And I could keep going and I could fill up this whole entire thing of what it's going to be. But I just want to refer back to the line that we had on the last slide. So if I plot those points, let me plot them in black. If I were to plot those points, I'm not going to connect them with a solid line. I'm just going to plot the points for you. You'll see that all of the points that have a y value that's greater than the x value is going to be above this line. So the way that you would actually graph this, instead of me putting a solid line, what I would do is just draw a dotted line to represent that it's not on the line, it's not including any of these points, it's just going to be above. So I would draw my dotted line, and then I would shade everything above. So anything in this area here, anything in this area is going to be, sorry guys, anything in this area would be a solution. So other points that I could just easily identify here would be, I'm going to put them in blue for right now. Here's a point, right? 3, 5 is a point because the y value is greater than the x value. -6, -4 would also work. Points that are definitely not a solution would lie over here, right? All the y values are going to be actually less than the x value on this side. So that would be not okay. Up here, this is where all of your y values are greater than x. Now let's move on to like a little bit more of a challenge. So actually giving you an equation or an inequality that is a little bit tougher than just y is greater than x. If we were to graph this, this would start on your y-axis at -1 because the y-intercept is -1 and the slope is 2, so it's going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or down 2 over 1, and it would create this line right here. We are not going to connect it with a dotted line this time because our symbol happens to be less than or equal to. So when it's less than or equal to, what we're actually going to do is we're going to still use a solid line because we're still representing things that are equal to. So I'm going to just draw this solid line. And now I'm going to shade in a specific area to represent where all the y values are less than 2x minus 1. So it's either going to be in this area over here or in this area over here. Your line is going to split your graph up into two different sections. So less than or equal to is less than, so it's going to be below the line, right? So I'm going to shade over here. And then this is where all my solutions are going to be. I'm just going to draw an S, and that just represents solutions. That's just easier for me to shade. But everything in this area here is going to be a solution. So like 4, 0 is a solution here, right? So like if I want to test out 4, 0, I can. So I'm going to just show you guys what I mean by that. So like, let's just say I have a test point. I find the test point and, sorry guys. So we're going to look at 4, 0. And if I just go to plug in my y value and my x value here, my y value is 0. So if I plug that in, that'd be 2 times 4 minus 1. 2 times 4 minus 1 is 7. Is 0 less than or equal to 7? And the answer is yes. So this test point works. So that means that we shaded in the correct area. You'll see, like, if we test another point out, so like if I test it out, let's just say, well, I'm going to test out something really, really easy. If I test out 0, 0, so this point right here, you'll see that it doesn't work. So if I plug in 0 for y, and I plug in 0 for x, 2 times 0 is 0, 0 minus 1 is negative 1. So we have 0 is less than or equal to negative 1. That does not make any sense. So that's how you know we shaded in the right area, because the point for 0 that we plotted before worked, and 0, 0 does not. Looking at this example, again, same exact thing. You want to graph your line first and then deal with the shading. So I'm going to look at my symbol. My symbol is greater than or equal to. So I know since it's equal to, it's going to be a solid line. So I'm going to start at 4. And I'm going to go down 3 over 1 because my slope is negative. So it'll create a negative line. I'm going to go up 3 from this point over 1 to the left. And then I'm going to connect it with a solid line. And now if I'm confused where I'm going to shade, what I'm going to do is I'm going to test out a point first before I even start shading so I don't mess it up. This is like kind of difficult because it is a negative slope, so the graph kind of looks weird of what's going to be like above or below. Usually greater is above, and less than would be below. But for here, it's kind of difficult to see what's going to be above and what's going to be below this line because it's a very steep slope and it's negative. So I'm just going to test out. I'm going to test out a point here and just see if it works. And I know if it works, then I shade in that area. If it doesn't work, then I don't shade in that area. So let's test out the point. Let's just test out the origin because that's really easy. So I'm testing out this point right here to see if it works. If it works, I'm going to shade there. If not, I'm shading over here. So I'm going to plug in 0, 0. And then here I have 0 is greater than or equal to, this is going to be 0 plus 4. 0 is not greater than or equal to 4. So I know that 0, 0 is not going to be a solution. So I know that I must have to shade over here. So this is where all my solutions are going to be. In this area over here on this side of the line, not this side. And if I want to just test out another point, I can do that. Just to make sure that it actually does work and I didn't make a mistake somewhere. So if I go to test out, let's just say I go to test out, let's test out 4, 0 again. My y value is 0, my x value is 4. This is negative 12 plus negative 12 plus 4 is going to be negative 8. So is 0 greater than or equal to a negative number? Yes, it is. So I definitely shaded in the correct area. And please remember, because I just forgot, please remember to put your arrows on your lines. This is going to be like our last example here, actually the second to last example. So you'll notice that this example is not in y equals mx plus b. So before you graph it, you most likely are going to have to change it into slope-intercept form. So I'm going to just do that quickly. I'm going to change it so it's the y is basically by itself. So I'm just solving for y. So I'm going to subtract over the 2x first. I'm going to subtract over the 2x to the other side. I'm going to be left with 3y. Is greater than or equal to negative 2x plus 9, and then I divide by 3 to get y completely by itself. Remember to divide everything by the 3, not just one of these terms. Both terms get divided by 3. And then negative 2x divided by 3, I'm going to rewrite it so it's just the fraction, the coefficient in front of the variable, and then 9 divided by 3 is 3. So I know my graph starts at 3, and then it's going to go down 2 over 3 down to over 3, or up to over 3 to the left, up to over 3 to the left. This is going to be a solid line because it's equal to. And I'm going to put arrows on my line. And now I need to figure out where to shade. So my symbol right now, if I'm looking, is a greater than or equal to symbol. So I know that means definitely I'm going to shade above. So automatically you should be thinking I'm shading in this area. If you don't know, test out a point and make sure it works. So let me just test out. I'm going to test out 3, 4. So I'm going to test out this point right here. And just make sure that it works. So I'm going to plug in actually into the original. It's always best to plug into the original inequality or equation that they give you, because you might have made a mistake over here and you don't even know. So I'm going to plug into 2x plus 3y is greater than or equal to 9. The x value is 3. The y value is 4. And yeah, that's going to be clearly greater than 9 because this is 6 plus 12 is definitely going to be greater than 9. So this would work out. And then our last example, x minus 2y is less than 10. So it's exactly the same issue. We have to change it so that it's in slope-intercept form first before we start graphing. So I'm going to move over the x value. And then for this example specifically, this one's kind of complicated, or not that complicated, but there's always like a trick or like that always gets students here. So I would just make sure that you remember that when you divide by a negative, you need to flip your inequality symbol. So here it's going to be y is, since I divided by a negative 2, I'm going to flip it. Y is greater than 10 divided by a negative 2 is negative 5. And then negative divided by negative, so that's a negative 1, right? Negative 1 divided by negative 2 is going to be positive 1/2 x. And if you want to rewrite it, fine. Y is greater than 1/2 x minus 5. And then from here, I would go down to negative 5, plot that point, go up 1 over 2. It is not a solid line because it is not equal to, it's just greater than. So I'm going to use the dotted line here. And I'm going to put my arrows on my line. And it says greater than. So this one's pretty easy. Greater than means above, right? Greater than. So I'm going to shade above that line with a giant S. Again, you could always test out a point. So I see that an easy test point here that is in my solution set is 0, 0. So I'm going to go ahead and test that out just quickly. Again, I'm going to use the original. And I'm going to test out that point 0, 0. So here I'm going to have 0 minus 2 times 0 is less than 10. And it will definitely be less than 10 because 0 minus 0 is 0 and 0 is less than 10. Remember to change your inequalities into slope-intercept form if you needed. If it is less than or greater than, make sure you draw a dotted line to represent it because it is not equal to. If it's equal to, you draw a solid line. Have a good day, everyone.